Okay, thank you. Thank you for attending this talk. I'm very happy and honored to be here today with you all. My name is Anthony Kim, and I'm from Samsung Research America. So Samsung Research America is a subsidiary of Samsung Electronics, and that's in Mountain View, California. Today, I'm going to talk about a machine learning approach to time-sensitive data analysis. At the higher level, it will be about how we turn machine data into smart data to better understand the user behaviors. Okay, and this talk would not have been made possible without contribution of my team members. So I would like to thank Jaemun and Sai for their contribution in machine learning. And I would like to thank Byunjin, Chanmuk, Jimbom, and Wongun for their work in feature engineering. So feature engineering is like a huge work that has to be done. And I also thank Kwang-hyun and VP Chu Lee for management support. And they are, we are the team that is like a multinational. So the work has to be done remotely and sometimes in person, and that was a lot of work. I really thank all of the team members for their contributions. So the big picture, and as well as the mission, what we do is we turn big data into smart data. So when I say big data, is usually a machine-oriented data that is event level. So Samsung has lots of products, and the products actually generate a lot of events. And we take those event-level data and then transform that into a smart data to understand user behaviors. And that's possible through what we call audience science. So audience science is a set of technologies to analyze user behavior and understand user behavior so that we extract business insight out of the user behaviors. And why we are doing that is because we want to drive value creation. And what kind of value creation we want to do is as follows. So we want to do, first of all, get actionable business insight for executives. And we also, at the same time, understand user mainly to serve them better and make their product use experience better. And what we all want to achieve is satisfy our product users as much as possible. And lastly, we want to actually increase the efficiency in analyzing big data. So when you talk about big data, it's a huge amount of data, and that's costly to analyze. And we want to actually make it efficient so that we easily extract insight, we easily actually better serve our users, and that's the main thing that we want to do. And how we want to do is the following. So we want to actually interconnect all of those things together, devices and users and smart TV apps and smart TV services and markets. Connect them all together using location and time information. That's our goal. During this talk, I'll be focused on how we use temporal information. So I already mentioned machine-oriented, the organic logs. So we see a large volume of data daily. It's about more than several terabytes a day compressed. If you uncompress it, it's even larger. And due to the large size, it is very costly to do it on a regular basis. Analyzing, extracting insight, and so on. There are two main kinds of data my team deals with every day. So one is ACR logs. So ACR stands for automatic content recognition, which means that we automatically recognize the publicly available content broadcasted on air so that we know who watches what TV content for how long time. The other kind of data we analyze is smart hub logs. That tells us how our users navigate through TV menus, as well as what kinds of app, what specific smart TV app they use, and what TV features they like. So we analyze those two main lines of data, and then turn that machine logs into human-centric data. That's smart data we actually talk about. And one of the, some of the smart data includes hierarchical sessions, user profiles, user segments, household profiles, and household segments, and so on. So we use those smart data and move forward to build a human behavior model, and then understand user better, and then serve user better. So it's going to be about the set of three things: observe customers, and know customers, and serve customers, and it's circulating. And that's our business-driven business. That's what we aim to do, using AI and all that big data technologies. And these are the application of the smart data. So we want to use machine learning and data mining models with smart data we generate to do targeted advertising and marketing and personalization, a lot of personalization, including a recommendation of content and recommendation of goods and so on. Here I describe a little bit about what I mean by session. Previously I talked about hierarchical sessionization, and here's a very simple example of sessionization, not about hierarchical though. So the devices like smart TV send event to a centralized servers. And I said it's an event level because whenever some event happens, it describes, what happened, at what time. I joined Samsung 4 years ago, and at the time, I couldn't even see the local time. It was all UTC. So basically, at what time, who did what. So for example, Anthony watched some TV show, season 1, episode 1, on some channel. That is one event. And that is repeating. If I actually stayed on the same program, that's repeating until the completion of watch behavior, right? So what we want to do is, instead of looking at those a lot of events, we want to actually consolidate those events with the same state into one data point. And that one data point is what we call the session. And that the process to consolidate data point into sessions is called a sessionization. So here we see one program watch session. Anthony watched this program, season 1, episode 1, at channel 1, from 8 p.m. to 8:30 p.m. So that is one session. And since we deal with a large volume of data, 4 years ago, it was possible to do sessionization with technology like Spark. But nowadays, I cannot even think about it without doing it without Spark. So we use Spark extensively for this sessionization work. And recently, we moved forward to do a more sophisticated sessionization called hierarchical sessionizations. So what does this do is the following. So it introduces multiple layers, from top layers to layer 6. And on top layer, what we do is consolidate the events, telling us about when the TV was turned on and when the TV was turned off. By consolidating those all events, we know from what time to what time the TV was stayed on. And then use that information to understand how long people use TVs. On the next layer, layer 2, we consolidate event by HDMI port. So what that means is the panel display session is connected to one or more input source sessions. And so it's basically breaking the panel display session into multiple input source sessions. And we see, okay, how much time was spent on HDMI port 1, HDMI port 2, and so on. And we know when you switch from, okay, port A to another port, say B. Layer 3, we also get the information on the type of devices connected to specific HDMI port. And that is possible because a lot of HDMI devices are self-describing themselves, telling us, okay, what is the name of the device and what is the manufacturer name. So by using that information, we know, okay, how much time you spend on what type of devices. For example, set-top boxes, or game consoles, Blu-ray players, and so on. And moving on to layer 4, so since we know the type of the devices, we also know what exact model you're using, whether it was the Microsoft game console or Sony game console, and so on. And that way, we also see, okay, how popular each device is, looking at the data. Layer 5, if we are using devices like set-top box devices, and that device is to view the TV content, the linear TV programming or the cable or TV programming. So when you do that, you have a technology called ACR to recognize what channel you're on and what program you're watching. And so the HDMI, no, actually input source session and device session can be connected to the content provider sessions as well as content sessions. And this is very powerful because we know how popular any given program is at any given day. And that is very powerful thing for us to understand, okay, what kind of program you're interested in, what channels you like, and so on. Here I talk about the proprietary technology called Samsung Taste Graph, and I'm the principal inventor of this technology. So this is Samsung's trademark and patented technology to understand program watch behavior in the following way. So we see the historical data, the 6 months long viewership data, and see, okay, what TV programmings were available in the past 6 months. And then group those programs into 22 different buckets, the taste buckets. And that includes 6 sports, football, baseball, basketball, ice hockey, soccer, and golf. And those are 6 sports games categories. And we also have comedy, drama, reality, talk show, and news. So a lot of people are interested in watching those kinds of programs. And we also have animation, the education, food, cooking, food/cooking, actually, and documentary. We also have music, fashion, travel, and business/finance. And we also have action, science fiction, and kids categories as well. So there are 22 categories that Taste Graph uses. So it's looking, it is possible because we have sessions, historical sessions, and then can compute how much time you spend your time on specific type of programs. Now we talk about 22 different types of programs. And since we can compute how many time you spend on each of those types of programs, we can say, okay, you have this many tastes belonging to you. The taste graph was invented to overcome the limitation of the clustering algorithms, like k-means. So by default, when you use k-means, each cluster, so each user cannot belong to multiple clusters. and each user has to belong to one cluster. That's the limitation. Also, you have to set what the K is, like how many clusters you want. We wanted to overcome that limitation, and we wanted to do the computation efficiently. That's why taste graph was built, invented. So this taste graph is widely used within Samsung these days. So I wanted to introduce. Since my talk is like my journey as well as Samsung's journey from machine data to smart data, and this is part of it. Moving forward, we wanted to do more intelligent things. So instead of looking at events or sessions happen at any time, let's actually view day as this way, the horizontal blocks of time. What we do is break the time into multiple time blocks in series. So for example, one day can be broken into 48 time slices, 30 minutes each. And when you do that, you can view the time from a slightly different angle, vertically. Since days are stacked vertically, if you view this time slice column, it's a way to view the historical information happened during this specific time slot. And n can be any arbitrary number. So what we do is we look at your historical behavior formed during this any specific time slice, and n can be year or many years. So one of the time unit was time slices. We also use day of week. Only difference is instead of days we use weeks. So on Monday in week 1, what was observed? How much time you use TV on Mondays in the past n weeks, right? And Tuesday in the past n weeks. And comparing that number to other days of the week, what's the fraction of your time spent on Monday and Tuesday and so on. We also have weekdays and weekend as a different time units. So how much time you watch TV during weekdays versus weekend, that's also important pieces of information. We also have day parts. The day parts are commonly used time unit for the advertising businesses. So we have prime time, late news, and so on. So during any given day part, what was the observation? So we fill in all of those blanks and then use those information to drive intelligence using machine learning and data mining models. So before moving forward, actually I wanted to mention the application of these time-sensitive features, we call it time-sensitive features, are the proprietary time-sensitive taste graph. So I talked about taste graph, and the difference here is we want to know what your tastes are at some given time unit. So your tastes may change depending on what time of the day it is, or what day of the week it is right now. So we wanted to capture your taste depending on time unit that we use. Also, there is a proprietary quality score. So that is to measure the relevance score between the user and any given content. And that's for that was developed to actually help Samsung's own advertising business. So far we talked about statistics, how we use statistics to drive value creation. And this slide, I start to talk about machine learning. So we haven't talked about machine learning, how we use machine learning yet. Now, since we have a lot of hierarchical sessions, and we have a time-sensitive features, so to speak. We can transform those time-sensitive information into feature vectors that machine learning can use. And it's not only time-sensitive features, we also have keyword-based features. So based on the program you watched in the past N days, what were the common keywords? Yeah. What were the occurrences of each keyword? And what were the occurrences of some popular program titles? And how many times you watched the program for 1 minute, 2 minutes, 3 minutes, 1 hour, and so on, or more than 1 hour. So we tweaked the features, we tweaked information that way, and came up with more than 7,000 features, and used those features for the demographics prediction. And this is household level demographics prediction. So that means even if we know household identifiers and person identifier like this, we combine the feature vectors of all household members in the same household into one feature vector. And the labels include things like age group and gender and so on. So what we want to do is basically know whether your household includes one or more male or one or more females, and a person with age group and age from age X to Y. So it's basically described here. And that was made possible thanks to the power of Apache Spark, MLlib, and TensorFlow. And we used all those power on the Databricks platform, the unified data analytics platform. And when we use TensorFlow, we use TensorFlow through the Uber's open source project called Horovod. So using all those power on Databricks, and and using the technology like ACR, automatic content recognition, as well as EPG, the electronic program guide, we were able to build a model yielding the result with a very high accuracy. So what we do is we have a third-party data having labels. By the way, we don't have any household, the demographics labels, for example, gender and age group. We don't have that information. But there are third-party vendors who have that information. So we license the data, and their data looks exactly like the ACR data, our proprietary data. So we train model using third-party with labels, and use the algorithms available through MLlib and TensorFlow. We built many models, machine learning models, train the models, and then do cross-validation. And that's where we are right now. This is ongoing work. And you see the accuracy here. What we want to do eventually is transfer that learned model to the actual, the proprietary data domain, the ACR specifically, and to do the prediction. And why Databricks? Why we had to use Databricks? Because it is very suitable for a wide range of user groups within Samsung. So Samsung is such a large corporation. There are 500,000 people worldwide, counting full-time employees only. So it's a massive organization. And there are many, many different groups stemming from the analytics groups or strategy groups, engineering groups. There are so many different groups. We want to give them power to analyze the data and analysis of their interests, of course. And Databricks is pretty much interactive environment, so anyone can quickly learn and interact with data that we have. And it was cost effective to use Databricks because based on our observation, the process running time was faster. On average, it was more than 50% faster. And it was more stable compared to running jobs on AMR clusters on Amazon Web Services. So it was a wise decision to use Databricks for that reasons. And another important aspect is end-to-end machine learning life cycles. So since we are building a lot of machine learning models, we should have a way to manage to run the model efficiently. And Databricks is working very closely with us to make that happen. Support for distributed deep learning model training. Although you have an option to use distributed TensorFlow to build your model in parallel, using Databricks is easier because there is open source called Horrorboot, and using Horrorboot is very easy. It's like to build a model using TensorFlow on Databricks. So everything was very seamless, and we were very happy about using Databricks. So in summary, I talked about hierarchical sessionization. That was first step to transform machine-oriented data into human-centric data. And I described Samsung taste graph. That was a way to extract insight on what taste you have, what are the types of programs that you like, you usually watch. So, and that is pretty much statistics-based. And we moved forward, we came up with the time-sensitive features to do machine learning. And the application of time-sensitive features were proprietary time-sensitive taste graph, proprietary quality score, as well as demographics predictions, which is running on a Databricks platform. So these are all about using data to better serve users and better use the huge amount of data we have. And future work, potential future work will be, understand user behavior. For example, since Samsung is producing many different kinds of devices, collecting the logs, turning the data into smart data, and then get insight out of it. That means wherever you go, even if you're at home or even if you're at some venues or even if you are moving in the car, we want to be able to capture what you want. And that's essentially to serve you better. So thank you for your attention. Any questions?
So we have a couple minutes for questions. Are there any questions before the next session? One question? Yep.
You talked about the Sessionization earlier. I'm just wondering, how do you deal with or classify the proverbial channel flipper that every time there's a commercial that comes on, it's boom, different channel?
Yeah. So it's about actually ACR technology. So since we know what channel you're on, and we know what time that is in your local time, we actually look up information within electronic program guide to see what exactly you're watching at a time, so that we know what program title it was and so on, and how long you watched that program. Does that answer your question? Okay, thank you.
Thank you for the presentation. Besides deep learning algorithm, did you use any other algorithm to do the prediction?
We tried two folds of a machine learning algorithm. One is a general machine learning, for example, logistic regression, random forest, and another fold is deep learning. We don't actually try any specific type of deep learning technologies. We just had a normal, typical deep learning with several layers to do the prediction. And those are equally likely at this moment
Okay.
in terms
And,
of the performance.
and the follow-up question on that is, did you use GPU for deep learning, or you just use a traditional CPU to compute?
Yes, we do attempt to use GPU because it's faster to train the model. And when you use Horrorwood, it's easy to actually use GPUs. So use the power of GPU and the power of TensorFlow all come together and help us train the deep learning model fast.
Oh, okay, thank you.
Yeah, no problem.
All right, one more quick question. So we have the next group coming in, then we'll wrap.
Hey, Anthony. My question is, when you do the taste graph, right? You do the clustering. Then how do you label those clusters?
Okay, so taste graph is relying on the genre information that electronic program guide provides. So I mentioned ACR, and when you use ACR, we know what program you watch it. And as a result, we also know what genre the program was associated with. So taste graph was a way to actually see what type of genres you were mostly interested in. And we combine similar genre into one, and that becomes an independent taste. So that what taste you have, that's the way that we know what taste you have.
So are you doing majority voting to get the label, or is there any other ways to do this?
Yeah, good question. So that's okay. That's okay. Yeah, we do try to do a majority voting, and only when we have multiple machine learning models and to predict demographical attributes. Since we have general machine learning models and deep learning models, it makes sense to do majority voting in the sense of ensemble approaches. So, and that typically actually boosts up accuracy. So we attempt to do that too. And this is experimental right now.
Okay, thank you.
Thank you again for a great talk. And if you have any additional questions, I'm sure Anthony will stick around for
Yeah,
that.
thank you very much.